Welcome to Brain Vision.
Hey guys, let's do problem 100. In this problem, we need to calculate the diameter of the pipeline. First, let us find the critical temperature and critical pressure of the components in the gas mixture. The components are hydrogen and butane. These are the two components, and for hydrogen we need to make adjustment using the Newton correction of 8 Kelvin and 8 atm. Now the components are hydrogen, which is having the critical temperature of 33.3 Kelvin, and the critical pressure is 12.8 atm, and with hydrogen correction, with Newton correction, the critical temperature and the critical pressure of hydrogen are 41.4 Kelvin and 20.8 atm. And another component is 1-butene. Critical temperature for 1-butene is 419.6 Kelvin and critical pressure is 39.7 atmospheric pressure. And the temperature and pressure of the system given is, the temperature is 50 degrees Celsius. Let's convert it to Kelvin scale. And the pressure here given is 10 atmospheric pressure. Now we need to calculate the pseudo-critical temperature and pseudo-critical pressure. Let's do that. The pseudo-critical temperature and pressure can be calculated using the K's rule. The K's rule is the mass fraction, the mole fraction of a substance multiplied by the critical temperature of the substance plus mole fraction of another component and the critical temperature of that component. Here the mole fraction of hydrogen is 0.15 and its critical temperature is 41.4 Kelvin, and the fraction for 1-butene is 0.85 and the temperature is 419.6 Kelvin. Therefore we get the pseudo-critical temperature as 362.9 Kelvin. Similarly, the pseudo-critical pressure is 0.15 multiplied by 20.8 atmospheric pressure plus 0.85 multiplied by 39.7 atmospheric pressure, and the pseudo-critical pressure we get is 36.9 atmospheric pressure. Now we can calculate the pseudo-reduced temperature. The pseudo-reduced temperature is the given temperature of the system divided by the pseudo-critical temperature. The temperature is 323 Kelvin and the pseudo-critical temperature we calculated 362.9 Kelvin. Therefore the pseudo-reduced temperature is 0.89 and the pseudo-reduced pressure is the pressure of the system divided by the pseudo-critical pressure, and we get 10 atmospheric pressure divided by 36.9 atm, which we get is 0.27. Now for this pseudo reduced temperature and pressure, the Z factor is the Z factor is 0.86. Now we have all the information and we can move and calculate what is the diameter of the pipe. We know that volumetric flow rate and the velocity of the product are related. We know that volumetric flow rate is equal to the velocity multiplied by the cross-sectional area, or we can write that volumetric flow rate is equal to velocity multiplied by pi r square, or velocity multiplied by pi diameter by 2 whole square. Again, we know from the compressibility factor equation of a state that volumetric flow rate is equal to the Z factor multiplied by the molar flow rate RT divided by pressure. Now we can compare equation 1 and 2, and we can write or we can solve this equation for the diameter. D square is equal to 4 Z n dot RT divided by velocity pi multiplied by the pressure, or D is equal to root over 4Z molar flow rate RT divided by nu pi pressure. Now we can insert all the values which are known values. The compressibility factor is 0.86. The molar flow rate given is 35 kilomole per hour. Let's convert it to minute per hour, kilomole per minute, by dividing 60. Then we get kilomole per minute. Gas constant is 0.0821 meter cube. Atmospheric pressure kilomole inverse 1, Kelvin inverse 1. Temperature of the system is 323 Kelvin. Velocity is given as 150 meter per minute. Pi is 3.14 and the pressure of the system is 10 atm. And when we do this calculation, we will get the diameter as 0.106 meter. Now we need to convert it to centimeter. Let's convert it to centimeter. Diameter is equal to 0.106 meter. To convert it to centimeter, we need to multiply it by 100. 0.106 multiplied by 100 centimeter, which gives us 10.6 centimeter. Therefore, the diameter of the pipe is 10.6 centimeter.